All right, so as we are getting started with simplifying radicals, let me say a few things first of all. Make sure we're clear on a few ideas. The first thing is that we are going to be using this skill with the next geometry content that we talk about, as you might imagine. But this is what I would put in the category of like a basic math skill. Not basic in that it's easy, but basic in that this skill is used in a lot of different areas. So it's just kind of like one of those little building blocks that we use to use in a lot of different mathematical concepts. So it's kind of like learning about addition and subtraction. We use addition and subtraction all the time. So it's just kind of a fundamental building block of a lot of what we do in math. So we're going to be learning about simplifying radicals today, and this will probably be new for most of you. But another thing we need to talk about is what is it exactly that a radical is? Now, you can see on the diagram, you're looking at something different on your page. It's square root basically, but anytime we have that sort of notation right here, that square root, we call that a radical. And I'm not sure actually where that term came from, but just be aware that that's what it's referring to. And when we are looking at a square root, so let's look at something real quick. Square root of a number, x, what does it mean if I say the square root of just any given number? You can plug a number in there if you'd like, but what does the square root of a number mean? There you go. So we're looking at some number that will multiply, so I'll make this x squared. So x will be the answer here because we could say x times x will give me x squared, so therefore the square root of x squared is just going to be x. All right? So it's really essential to understand that idea, which is not new information for you. You should already be aware of that, but just a reminder here. And we need to talk about something else, which is perfect squares. That term is used a lot in math, but what do you think a perfect square is?
When it's two whole numbers.
Okay, and you're right there. So what we mean is that if I have a square root, like let me give you a number real quick. The square root of 3, if you plug that in your calculator, are you going to get a whole number as your answer? No, you're going to get 1.7 something. It goes on infinitely far. One thing we're going to talk a little bit more about tomorrow is that this is what's called an irrational number, when you have these decimals that just never stop. But if I gave you square root of 4, what would that be? 2. We know that that's the same as 2 times 2. So square root of 4 is 2. So 4 is a perfect square. What's another perfect square?
25.
9, 25. There you go. So we can find our perfect squares really easily. It's just going to be, 1 times 1 gives me a perfect square of 1. I'll go ahead and tell you, 1 is not going to be very useful for what we're going to be doing today. We're going to kind of ignore that one. But 2 times 2 is 4. 3 times 3 is 9. So these numbers that we're coming up with, these are our perfect squares. I'll just do a few more. 4 times 4 is 16. 5 times 5, like you already mentioned there, is 25. And I'll just do one more. 6 times 6 is 36. All of these numbers right here are perfect squares. Wait, why did I inverted that? I wrote 63 instead of 36. All right, sorry about that. So all these numbers right here are perfect squares. And it continues. 7 times 7, 8 times 8. These are found up here at the front of the room on this multiplication table. It's the white numbers right here. These are special numbers in math. And these are numbers that we are going to be working with today. Now, the ones that you see here, this goes from 1 times 1 up at the very top left corner down to 12 times 12 at the bottom right. These are the only perfect squares that we're going to be concerned with. And typically, we don't even care about anything higher than maybe, honestly, we could use any of these, but a lot of times it might be down in the lower numbers. So we need to know what a perfect square is. And this is useful because anytime we have a perfect square, like this, we already looked at the square root of 4 right here, but I can plug any of these other ones in. Square root of 25 is 5. Square root of 81 is going to be what? 9. Let's try this one. Square root of 121, what's that going to be? 11. All right, that's another one. It's on the board right here. So, these are really helpful because we get a whole number anytime we get the square root of a perfect square. All right, so those basic ideas in mind, what we're going to be looking at today is how we can simplify radicals when we don't have a perfect square there. Okay, so let's look at this real quick. And your page looks like this. What I'll do is I'll turn the lights off so you guys can see up on the screen a little better. And we're going to simplify. Let's just start with number 1, and I'll talk through the process. And we'll go through a couple of these until you guys are feeling like you understand it. So right now, just on your calculator, plug in the square root of 96. What do you get? 9.8. All right, so that's approximately equal to 9.8. We're not interested in that decimal right now. There will be times we'll come back and the decimal will be fine, but we need to know how to simplify. So we can't just take the square root of 96. What we can do, let me show you a couple of operations we're allowed to do with radicals. All right, so I could rewrite this as the square root of 2 times 48. And you can verify those are factors. So 2 times 48 gives me 96. So I can rewrite it that way. And if I have that, and if you're writing this down right now, you'll erase it in a minute. We're not going to stick with this. But I could also rewrite this as the square root of 2 times the square root of 48. So I just did a couple of things here. I just took this one number under the radical and I split it into factors and multiplied them. That's allowed. And then I took these two numbers under the same radical and split them into their own radical. And that's also allowed. Okay. So is everyone good with this so far? Okay, so now let's actually solve this and simplify it. All right, so 96, we talked about the perfect squares and talked about the fact that we can split this into 2 different square roots multiplied together. So my approach is going to be, what is the biggest perfect square that I can, that's a factor of 96? And this is where it might just be some grunt work, where you're just plugging and chugging until you find the biggest number. But I mentioned that we can always skip 1. 1 is going to be a factor of every number, and it doesn't help us in any way. So I'm going to skip number 1, but I'm going to try number 4. Is 4 a factor of 96?
Yes, but it's not.
It's not the biggest, so I could write this. I could have 4 times what?
96 by 4.
Yeah, 4 times 24 is 96. Now, your strategy, if you're looking at this, in your calculator, you say, is 4 a factor of 96? So I have to do 96 divided by 4, and I get 24. So it works. That's good. But your strategy in your head is you might be thinking, okay, yeah, 4 works, but I'm left with 24. Could I find a bigger number that will still divide evenly into 96? And you can, right. I'll ask you that in a second. So you're going to look at what's left over, and that might give you a clue. Can I keep going? All right. So let's try the next one. If we tried 9, does that one work?
No.
Yeah, 96 divided by 9, that one doesn't work out for us. But the next one, what?
So last time the biggest one, it was 16. Yeah.
16 times what?
16 times 6.
Okay. Now, we could keep going, though you are going to figure out pretty quickly that is the biggest one. You could try. Now, some of these you could logically skip. I hope you could figure out 25 isn't going to work. All right? But 36 is pretty tempting. I might try that one. But if you try it, does that divide evenly? No, it doesn't. So, go to the next one that seems logical, and then if you get to a certain point, you realize the smallest factor that you can end up with is 2. Right? So if you start getting to numbers where if I divide by 49, it's going to be 49 times 1.9 something. I can't remember. So it's like, okay, I've kind of found the biggest one. So anyways, now we've gotten this. So if you're following the logic here, I can say this. That's the same as the square root of 16 times the square root of 6. And I know what the square root of 16 is. What is it? It's 4. There you go. So our final simplification is this. 4 square root of 6. We want the number under the radical to be as small as possible while still being a whole number. And that's not fully showing up there. So there it is. All right, we can try another one of these. Let's real quick look at number 6. We might be able to answer that one quickly. What is the square root of 144? It's 12. This one happens to be a perfect square. So if you can identify that, then you can save yourself a bit of work. So square root of 144 is just 12. And you don't even have to have that memorized. This multiplication table will stay up on the front. And if you find it helpful, you can even write down your perfect squares on your own paper or on your iPad somewhere so you can refer to them. So we are really focusing on the perfect squares when we simplify. Okay, so is there another one on this page you guys would like to look through? I'm going to try number 2. Okay. So luckily, it's the same process for every single problem. So with 216 being the number I'm looking at, I want to find the biggest perfect square factor that can go into it. So, what's that? 18. Well, remember, it has to be a perfect square factor. So the only numbers I'm even trying are these numbers that are in the diagonal right here. So I'm going to try 4, see if that works. Does it? Yeah, 4 does work, but you can probably guess there's something bigger. And then I'm going to try 9. And then I'm going to try 16. And then 25, and so on until I find the absolute biggest number that works. All right, have you guys had a chance to try dividing these numbers until you find the biggest one? Anyone out there, what did you find as your answer? Okay, let's just try it together. We already decided that 4 works, but let's see. Does 9 work? 9 times something, does that give me a perfect square? What is it? 24? Is that right? Okay, so that one works. We might be able to do better than that. 16, does it work? It doesn't. It seems like it should, but it doesn't actually work. What about 25? And you might have skipped that one because you might have known that it wasn't going to work. What about 36?
But I know what it is.
Well, 216 divided by 36 is what? 6. All right. So this is looking promising. Is there anything better?
Yes, 49.
49 doesn't quite work here.
98?
Nope, we're looking at number 2.
Oh, never mind.
All right, so 36 is our biggest perfect square that can that's a factor. So now, from there, it's just square root of 36 times the square root of 6. Now, some of this is just extra work to really clarify what we're doing. But if you don't need to do this on your own work, then you can kind of skip writing out every single thing. So my final answer is going to be what?
6.
Well, 6. Oh, I see what you're saying. So we'd say 6 square root of 6. Okay.
6, square root of 6, why is that?
Well, when we notice what we did, we changed it to 36 times 6, because that's the same as 216. And 36 is a perfect square, so we can just say that that's the same as a whole number 6. But that radical right here, the square root of 6 is left over, that doesn't go away. We still need to account for it. So 6 times the square root of 6 is what we're looking at here.
Oh, to get 36. So
Yeah, in order to get
equals-
36, and then therefore square root is
So
216.
whatever is in that last equal is going to equal that first square root.
Yeah. So you could plug both of these in your calculator. This is a way of checking. You could plug in square root of 216 and get some number. Well, it's probably going to be about 14 point something. All right.
No,
So,
you're not looking for the biggest number, you're just looking for the perfect square.
right. You're looking for the biggest perfect square. Because that's not the biggest factor of 216, but it's the biggest perfect square factor of 216.
So
And you could also plug 6 square root of 6 into your calculator, and it should be exactly the same number.
So 108 wouldn't work?
No.
Oh, because it's not.
Right, it's not a perfect square. Right. Okay. Is this, any other questions on these? All right, why don't you guys pick any problem you want on this half of the page. You'll notice there's the first half of the page, about 12 problems. So you can look through those, and then we can maybe look through one more of these in a few minutes before we move on to the right side. All right, so I want to show you guys the biggest error that I see happen a lot. And hopefully, and maybe we could look at this with number 10. So number 10 doesn't look too bad. It's just square root of 12. Square root of 12 itself that's not a perfect square. So we have to kind of come up with a way. What is the biggest perfect square that can factor into this? 4. Again, we're only looking at these numbers along the diagonal. So even though 6 is a factor of 12, it's not a perfect square factor. 4 is. So I can rewrite this as 4 times 3, and then rewrite this as the square root of 4 times the square root of 3. And here is the biggest mistake that people make. This happens all the time. So try and catch yourself if you find yourself falling into this habit. The square root of 4 is what? 2. Whole number 2. And people know the square root of 4 is 2, but people will write this a lot. And this is the wrong thing. People will write this, square root of 2, as their answer. Because people forget when you take the square root of 4, you get a whole number 2. Not a square root of a number. All right? So that'd be 2 times square root of 3, and then we're finished with that one. All right, are there any other problems on this left side of the page you'd like to go through as a class? 12? All right, let's look at 12. I figured 12 would be one you'd want to look at. So that 9 that's out in front, this is something that we can kind of ignore for right now. Just kind of set it aside, and we'll come back to that. So I want to think of just what's under the radical. What is the biggest perfect square factor that can go into 245? Well, 24 is not a perfect square.
I'm trying to look at that. Let's try 144.
Well, you can try 144. You can try 121. You can try, okay, here 49. 49 times what? 49 times 5. And so did anyone try a bigger number that still worked? And again, you can kind of base this on what's left over. When you do 49, you have 5 right here. We're really not, mathematically, if you want to kind of understand what's happening, when you have 49 as a perfect square times 5 that's left over, you have to kind of look at what's left over, the other factor, and say, are there still factors of that number that maybe I could pull out? is there still a perfect square factor of my remainder? And you don't have to think through this because this might confuse you. So if it does, just remember, keep plugging and chugging until you find the biggest number that works. But if you want to dig into it a little deeper, you could say this. 5 only has 2 factors, 1 and 5. Neither of those are a perfect square, so I'm done. We could look at another example real quick. Let me find a good one. This 216 was a good example. So if I had left this, I'm going to go back up to the top real quick, and I don't want to confuse you guys by saying this, but square root of 216 could be written as the square root of 4 times 54. That's not my biggest perfect square factor because 54 could be split into 9 times 6, and 9 is still a perfect square. So there's still a perfect square that remains. I need to keep going until I find the biggest number. All right, so let's come back to this. Yeah, 49 times 5 is what we've got. So if I keep working with this, 9 times square root of 49 times square root of 5. What is the square root of 49? 7. So now this is 9 times 7 times square root of 5. This is where that 9 comes into play. That 9 has just been hanging out in the front. But now we have the 7 that we can multiply by, because these are now like terms. They're both whole numbers. And we can get, what is our final answer? 63 times square root of 5. Okay.
Why the times 5?
Well, remember, this square root of 5 that we've had on the right side doesn't just go away. We have to account for it.
I know, but how did it get there in the first place?
Well, 49 times 5 is the same as 245.
Oh.
No. Okay, so now let's look at the last part of this. We still have time. I know it looks like we have to go through a brand new concept, but really this is the hard part of what we're doing today. The next part where we're multiplying square roots together, this just adds one extra thing we need to do, and then it looks like any of those other problems. So when we are multiplying radicals like this, and I'm just going to look at number 1 real quick. Just like we did before, we took 2 numbers and we split them into their own radicals. Now we're going to combine them under the same radical. So this is the same as square root of 5 times 5, which is the square root of 25. And at this point, this is just like any of those other problems we had before. So what is the square root of 25? 5. This one happens to be a perfect square. And that makes sense if you go back to the very beginning and kind of look at that. You might have guessed that square root of 5 times square root of 5 is going to be 5. All right, so we can look at one a little more complicated, even if it doesn't seem complicated. Number 4 right here. Actually, let's do number 2. Number 2 seems really straightforward. So let's just combine these together. We've got, instead of square root of 10 times square root of 2, I'm going to have square root of 10 times 2, which gives me the square root of what? 20. At this point, it's just like we had on the other side of the page. So you can see this doesn't change things a great deal. So we can find the biggest perfect square factor of 20. Does anyone know what that's going to be? 4 times 5. There's nothing bigger that works. This one won't take you as long to figure out. So this is going to be 4 times 5. And of course, we can just solve from there, which is going to be square root of 4 times the square root of 5, which gives me a final answer of what? What is the square root of 4? 2. So I can just change that square root of 4 into a whole number 2, square root of 5. Did I lose some people along the way there? Okay. So again, I want to reiterate, this is kind of a fundamental math skill. We are going to use this with our next content, but you're actually going to find what we do with this isn't as complicated as what you're doing on this worksheet. All right, so the only other thing to mention here, and then you'll have about 10 minutes of practice and asking questions. Down here at the bottom, if we look at number 11, and any of these other numbers we could look at too if you have questions. But just real quick on number 11, notice that there's a negative in that problem, but the negative is outside the radical. So when I multiply these together, what I'm going to get, and I'm not going to solve this thing completely, what I'm going to get is negative, oops, I wrote that wrong. I'm going to get negative square root of 54. Okay? And it's important that that negative stays on the outside, because otherwise, if you start using your calculator trying to figure out what the square root of negative 54 is, that's called an imaginary number. You will learn all about those in Algebra 2. But for right now, let's just keep it real. Say that again?
How come you couldn't do a negative square root of 9 times square root?
Well,
Why do you have to combine them when there's already a square root of 9?
you're right. And this one, I'm just saying as an example. But yeah, to clarify, better is what Logan is saying. Right here, you might recognize a negative, or that square root of 9 is already a perfect square. What is it? 3. So we could actually save ourselves a bit of work here just by realizing we already have square root of 6 times negative 3. And then we can rearrange that to get our final answer. So you can look for that. I was just trying to show one thing in particular, which is when you multiply two radicals and there's a negative on the outside, keep the negative on the outside. It doesn't get brought inside. Okay. So I will let you guys work on that, and I am still available if you have questions, but you can spend 10 minutes working on that.